Hello. Before we introduce our next speaker, I just want to say a quick thank you to one of our silver sponsors, TraceBit. This conference could not happen without you, so thank you very much. So without further ado, I've got our next speaker, Sharan Patil, with Azure Arc, from a heartbeat to heart attack. Thank you.
Okay, just checking. Can you hear me? All right, fine, perfect. Cool. All right, morning all. Welcome to my talk on Azure Arc, where I speak about my exploit, where I was able to hijack a server that was enrolled in one tenant into my tenant without even compromising the other tenant. So let's begin. About me, so I'm a security consultant in the UK. I've got a bunch of CVEs and certificates, which basically everybody's grandma has at this point. I like NetSec, InfoSec, and I don't like anything else. Well, it's a bit ironic given I'm a consultant and my clients pay for the reports that I send. So if I like NetSec, why am I presenting on an Azure product? Well, the main reason is this is a hybrid setup, wherein you have a local agent and then you have your remote tenant, which is used to manage it. And I find it pretty cool. A new attack surface, a new lateral movement from an engagement perspective. So let's get going. So we are going to discuss about what is Azure Arc, what's the impact of compromising Azure Arc, and then we're going to look at how I exploited the patch for my exploit, and other further research that I'm doing. So disclaimer, a lot of talks over here are purely cloud or like cloud-focused. A majority of my bits is going to focus on exploiting the local agent. It falls under the umbrella of Azure Arc. The original proof of concept that I used to hijack the server was 20 minutes long, and unfortunately my talk is also 20 minutes long, so I will be briefly touching over the points where the misconfigurations happen and you could exploit it. So there are some key terms that I want you guys to get familiarized with, because I'll be repeating them again and again. So the first one is HIMDS, or Hybrid Instance Metadata Service. This is specific to Azure Arc only. Next one is Instance Metadata Service. I assume quite a bit of you would be familiar with it if you're working with Azure or AWS. And then we got LPE, or Local Privilege Escalation. Then AITM, Adversary in the middle, or Man in the middle. And then we've got C2, which is for command and control. So why did I focus on Azure Arc? So we have seen a lot of our clients start implementing or onboard the servers onto Azure Arc. Sometimes it's even the domain controllers. So you understand the impact of the compromise now. It's fairly a new product, well, released in 2019, but the increase in adoption and everything has been quite big from 2022. So this was also abused by a threat actor. Microsoft has also documented. I'll speak a bit about it in a while. And I personally believe this is a wonderful C2 tool for an engagement, wherein like you have Microsoft signed binaries doing your stuff for you. All right. So what exactly is Azure Arc? So it is a product that helps you to manage and integrate on-premise servers with Azure. The installer is present by default in Server 2025, as you can see, where you've got the advertisement in your Server Manager console, or you've got the tray at the bottom of the screen. I also think it's another Microsoft tool that makes a threat actor's life a bit easier. We're going to see why in a few moments. So this is the architecture diagram. I've picked it straight from Microsoft's documentation itself. So there's two bits. You've got your server, and then you've got your Azure tenant. So the hybrid instance metadata service, so that's the one which has your metadata, shares the access token with the other services, which need the access tokens to authenticate or interact with your tenant. Then we have the extension manager, which I'm going to focus on for my exploitation, where we've got the different extensions, which is like the custom script or MD, and then you've got the Azure Monitor Agent. So these are just a handful of them. There's quite a bit. I believe Datadog has one, and Dynatrace also has an extension from their own. In terms of the cloud bits, we got the Entra, which manages your authentication and authorization. And you've got the Azure portal or CLI, where an admin can use the given tools to work with the servers, like whether update it, patch it, or run any commands on it. So the advantages, it's the ease of management. So you've got one dashboard or one portal wherein you can work with your servers and your cloud resources. Better integration, so you don't have to work with any janky tools or anything or third-party tools. This just lets you integrate it. And it's a developing product, so new features are being added. And then we got code execution. So what I mean by code execution over here is, like, let's say you're a sysadmin, you want to run a script on the server, and you don't want to like log in or get your VPN or anything. You could like use the custom script extension, upload a script, and ask it to execute, and it does it on behalf of you. So you eliminate a direct channel of communication in there, all done through your Azure portal. So there are some key components, HIMDS as I mentioned. So when you install Azure Arc Agent on your server, so there's going to be another virtual service account being created. Surprise, surprise, the name is HIMDS. It's going to be repeated a lot. And it just has one task: synchronize the metadata and share the access token with the other extension services. It has its own set of log files. The location is program data, Azure Connected Machine Agent. So this folder is not accessible to low-privileged users. It is restricted to local admins and the system account. Next comes the extension service. So this is where it gets interesting, because the extension service executes as a system. So when it's system, it's like the highest privilege on a Windows, and executing anything over there is like you hit a jackpot. So its functionality is pretty simple. It installs, updates, and manages the extensions, and it's got its own set of like logs. It's in a different folder compared to the HIMDS logs. Now, these logs are quite verbose, really important for us in terms of like understanding what's going on, or troubleshooting, or if you're a threat actor, you really, really want to cover your tracks by deleting these logs. So the local communication channels. So as I said, HIMDS has two different interfaces that you can interact with. One is a REST API. Pay a slight attention, it's HTTP, not HTTPS, which is important in our exploit. It also exposes a name pipe. Surprise, surprise again, HIMDS. HIMDS is accessible only to the local administrator. So this pipe is the one that's used for managing, configuring, or modifying anything with the configuration. You also have another pipe where a low-privileged user could interact with the HIMDS service to query some metadata. And then we've got another CLI tool called AZCM Agent. So this is the command line interface that interacts with the name pipe. And obviously, we've got the extension and guest agents. So these communicates with the REST API over HTTP. There's also a few outbound service requirements. And if you visit the official Microsoft documentations, they give you a wildcard in the URL. So if you ever find yourself in a situation wherein you don't have an outbound communication with your C2 channels, you could use Service Bus. We have used it in a lot of engagements. Works out pretty good. It does cost a bit, but if you want to establish a channel, Service Bus, wonderful. And then you've got your blobs, basically to download or upload files, exfil, or whatever you would like to do. So I see this as really, this makes my life a lot easier on engagements. So let's talk a bit about HIMDS and IMDS. So there's a key difference between how HIMDS works, wherein you require access tokens for authentication. Access tokens requires authentication, wherein like there's a key file. You need to read the key file and send it to the HIMDS REST API, where it sends the access token for your tenant. Whereas in IMDS, all you do is like you send a GET request and you get the access token, so any user can request it. But HIMDS, you need to be a local admin because those key files are locked. That is a sample request for your IMDS. And for HIMDS, it's a little different. Again, I've snipped out a bit of the code. So basically, you're sending a GET request for a metadata, and it says like, oh, this is the secret file path. So this is in C program data Azure Connected Machine Agent /tokens. Again, accessible only to the HIMDS service and the local admins or the system account. And then we've got the access token, so you read the file, you send a request, and you get the access token, and then you use the access token. So what's the impact? So impact is subject to configuration. So let's say you just onboard your machine and you do not assign any privileges or anything as such. It's just a normal managed identity, basically nothing else. The worst thing that could happen is a local privilege escalation. And let's say you give access to your other resources or access to your key vaults for your secret managements and share it with other machines so you can get those secrets, if possible, have a lateral movement. But there's another case wherein if you're onboarding it via GPO, you could also have a lateral movement if there's like poor secrets management. Christian has given a wonderful blog and a talk. I would highly recommend reading to understand how it works. So state of the art, Microsoft has taken precautions to make sure it's only the authorized users. That means the local admins can access it. So as a low privilege user, I cannot stop the service. I require the access token where, say, if I want the access tokens, I need admin privileges, and I cannot see most of the, or majority of the configuration files itself. So before I started my research, this was the number of CVEs or exploits that were known. And when I started, all I could see was LPs everywhere. And we are going to be discussing about one particular case that I submitted, which is still in pre-release. Well, it was supposed to be released, but like the communication between me and Microsoft was like, oh, this is going to be released in April, or then it got pushed to June. Then it just kept on postponing. But I believe 8 months is a long enough time for a product to be patched. And this was pseudo-patched in version 1.53 in June. So 3 months from June, I believe it's a good time for disclosing this. And if you paid attention in the patch Tuesday, there were 2 more CVs released for this. So all the admins would be updating it. So I believe it is safe to disclose, but I won't be disclosing the entire proof of concept in here. So let's understand how the extension itself works. So you send a GET request to the REST API. You got the HIMDS, which sends your metadata back. And then you request an access token, but hang on a minute, you don't have the keys that is required for the access tokens. So it says, oh, I'm going to write this particular key into this particular folder. You need to fetch the key and send it to me so that I know you have the exact privileges that you needed. So a 401 unauthorized, and you send the location of the file. So extension service reads it and sends it in the next GET request. So it verifies if it's correct, you get the access token, and then you interact with your tenant. Right, so the S in HTTP stands for security, which doesn't exist. So if you find yourself in a position wherein like you are able to sniff the local traffic, you don't even need any request or anything. You could sniff the traffic directly and get the access tokens for the tenant. So please make sure you encrypt traffic in transit. Right, now the HMDS logs. So for the HMDS service to actually interact with your tenant, it needs some sort of data, right, to understand, oh, what's my like VM ID or anything or config as such. So this is the file where it reads from, and so far in my research, I'm happy to be corrected, but it's only the HMDS service that reads it. So the extension service requested from the HMDS. So if the HMDS service fails, the extension service is happy to like send a request to any service that's listening on port 40342. And inside the configuration file, you can see the subscription, the tenant ID, and you can look at the VM ID and the UUID. So the VM ID is quite important because once you get your access token, you want to speak with your tenant, but you need some identifier, like, oh, who exactly is speaking with me? So that's where the VM ID comes handy. So in the extension agent, we spoke about the key retrieval process, and then you can actually see the logs are very verbose, and you can see what exactly was the key file at what timestamp that was retrieved. So if you have your file creation or deletion logs, you can map it one-to-one and get going with that. So in the timer, once you get the access tokens, you speak with your tenant, and as you can see, there's no extensions configured, so it says, oh, there's 0 extension, and then it resets the timer to 5 minutes. HMDS also has a feature called Heartbeat, wherein it sends like a signal every 5 minutes, and this is also pretty similar, wherein like every 5 minutes it checks the tenant if there's any extensions. So this is a sample request. So as you can see, there's a VM ID used over there, and then the bearer token is the access token that you fetch from HMDS. So let's say you have an extension configured. So this is how the response is going to be from your tenant. And you've got the machine ID and basically what the extension is, where the extension files are that you need to download and execute. So why should we care about extensions? Well, Azure Arc extensions for C2. There's been a lot of research out recently. That is, I think in the past 3 months, we have seen at least 3 or 4 blogs. And majority of them are using custom script extension. Custom script extension was already disclosed, I believe, by NetSPI, or apologies if I'm wrong with the acknowledgement over there. And then you've got other extensions that you could use for like C2 channels. And this was also used by Pete Sandstorm in one of the campaigns, and Microsoft has documented it. Not much details is available. All they say is like Pete Sandstorm used it. So yeah, as I said, makes the life of threat actor very easy. Microsoft signed binaries doing your things for you. Taking a dig into the services itself, I find this very weird, wherein like HIMDS service dies after 2 attempts, but the extension service like keeps respawning even if it crashes. So that means HIMDS down, your extension service is still up, so that you need a listener on 40342. So from my research, let me see what happens when the HIMDS dies, right? So I am the HIMDS, and instead of sending the metadata for that tenant, what if I send the metadata of another host, which is enrolled in a completely different tenant? Turns out this is the original tenant that it was enrolled in, and I restart the service, send the metadata of another host, it just accepts it blindly. There's no validation if it belongs to that one, it belongs to that particular server or not. So let's do an adversary in the middle attack, wherein I am going to be the HIMDS for the extension service, but I'm going to be the client for the HIMDS service. So get access token and says, oh, you're missing authorization. This is where I write it. We get the file name and the path, and then we shut down the HIMDS service. And then the extension service does its work, and then it asks where the key file, it requests the access token, and we say like, oh, actually, you know what? I requested a key file. This is where it is written. Can you just fetch that and send it to me? Turns out it does. You can read the key. Great. So now you must be assuming, oh, we can send the access token to the HIMDS service, get the access token, and get the tenant. Well, no. Because on every HIMDS restart, I believe it maintains something in the memory, and during the restart, the previous keys that were issued are no longer valid. So that's a bit of a bummer. But and also another thing to notice is like the keys are deleted every 10 minutes, so you only have like a 10-minute window before your first key is requested and you restart the service. I was like, fine, fair enough. I know it uses a certificate for authentication. Can I use the certificate? Can I fetch the certificate? So I send the part of the certificate or like an arbitrary file. Turns out it doesn't accept it. It needs an access token. Right, now, I know the extension service doesn't validate the metadata. I know I can force it to read a file that I want. All I need to do is like find another exploit that stops the HIMDS service. Well, I had another CV coming in. So this was using the MSI exec repair. So version 1.48, when they released, they had a schedule task, which was like another beautiful thing that led me to 3 previous on the host. So there's a lab setup. I have a server 2022, which is under my control. I have a server 2025, which I want to exploit. And I have a Kali, which I'm using for my HIMDS service. So how does the attack work? So the server 2025 requests the metadata. I fetch it from the 2022, send it back, the metadata and the access token, and the server like speaks to my tenant, the one where I have my custom script extension, downloads and executes it. So this is where I initiate the repair functionality, and I do a port squatting. So as we all know, no 2 processes can listen on the same port, so I use that to my advantage. When the repair process is happening, the HIMDS service is down, the guest extension service is down, so a port squat works beautifully for us. And then on a successful hijacking, you can see the request coming to my Kali host. So as I said, the 200, 401, 200, the cycle is same. It never changes. So you know for sure this is how it's going to be. Next, I go in there, deploy my own extension. All I do is like, can you just write these files? So remember, it's executing a system. So whatever it does is going to be under system. So before we were RiverSec, we were called WithSecure. So that's why the name WithSecure. If you don't know WithSecure, we were F-Secure before that, and then we were MWR before that. So a lot of name changes, but we are the same people doing the same research. So the tenant, now it's fetched the extensions. As you can see, it says receive 1 extensions, which was 0 before, proceeds to install, and you can see it in your burp log when you intercept that, oh, yep, cool, the requests are going out. And then you can see, this is the command to execute, and that is my script downloaded from this particular blob storage. Remember the the interesting outbound requests wherein you had the, sorry, what was that? Wildcards. So this is where it's quite handy for that. So payload execution, so we had executed, and then there's files written. So whatever script you execute is going to be stored on the host as well. So make sure if you're a threat actor or on an engagement, make sure you cover your tracks, delete the file. That was basically the exploit, but we had a patch. So what was in the patch? So in the June release of version 1.53 that was communicated to me, I had a brief look. There was a new REST API. It was using port 40321, but they implemented HTTPS over there. So self-signed certificate, and there was certificate pinning. So good. We just can't use any arbitrary certificate or even another like signed certificate. So for the research, so far my focus had been on local agent exploitation itself. So that is done. I want to see other means of using the C2 channel in that rather than using the extensions that Microsoft has given. Is there any ways that I can use my own extensions or use my own requests or craft my own requests to have a C2 channel? So in conclusion, the hybrid attack surface just increased. You have another, like sysadmins should really know what extension or what exemptions they are granting for the service. The SOC teams have a new headache to deal with because if you observe, only the REST API that I had was just listening under my user ID. Everything else is under Microsoft signed binaries. So you got another lol bin to get going. So there's a bunch of community research. I highly, highly recommend reading them in no particular order. These were really useful for me to understand how the product works. A shout out to Mandiant and SEC Consult because I have found some more previsks based on their blogs, and my colleagues, Daniel, Jonas, Max, Emma, and Owen. That brings me to the end of my talks. Any questions?
Thank you. We've got a question over there. Joel? Yeah, the mic's coming to you. Thank you. Oh, it's in the green. Yeah.
Could you speak to the effectiveness of using tenant restrictions as a mitigation against your host connecting outbound to an unauthorized tenant?
Well, so here's the thing, though, because it blindly trusts whatever tenant you have, so you will have to have outbound like restrictions. Though I still haven't tried different like caps that you have or any other policies over there, but so far it just seems like whatever you feed it, it just believes it blindly and sends a request outside. I hope that answered.
Thank you. Any other questions in the room? Oh.
Yeah, we got one over there.
Just with the gentleman in the green over there. Could you raise your hand? Thank you.
Many thanks for the talk. I guess the attack would assume local administrative privileges to restart the agent, right? So this must be there already.
Sorry, I didn't quite get you. Like, for restarting the MSI service itself?
Yeah, you would.
No, you wouldn't need it. That's the thing that they haven't restricted low privilege user from restarting
thanks.
it.
Any others in the room? I have another question for you, Sharan. Sure. Are you currently seeing an increase in the use of Azure Arc in corporate environments?
Oh yeah, I have. Like I said, they have like even onboarded domain controllers. So you're just one like service principal secret away, or just one bad exploit away. So there's not. Luckily, there's no network interfaces. As far as I've seen, everything is local. So you need to be at least have a foothold to exploit it. But yeah, you never know with new updates, new exploits.
Mm-hmm. Any others in the room? Okay. Well, thank you so much, Sharan. That was incredible. Thank you so much.
Thank you.